Mathematica. Okay, now first 4 hours are belongs to mathematics only, means here in these 4 hours we are going to discuss only Mathematica. So nowadays researchers are using Mathematica directly. Suppose here they want to find some suppose there are say, some area research area with including mathematics. Suppose that may be differential equations, that may be plotting, that may be something else. Directly they are using. So for publishing papers, Mathematica for quick results. Okay, in the linear algebra as well as in numerical methods, you have studied many topics like solution of algebraic equations and linear system of equations, differential equations, in interpolation and differentiation, integration, and vectors. Okay, I think you studied many different kinds of topics. Okay, all those topics. Okay, you have some time to evaluate those things. But in Mathematica, within seconds, the result will come. Within results, all the results of whatever we discussed and other topics also. But at present, you don't have Mathematica software. But please listen a few things in between. I will ask to solve you. Okay, there are many online solvers are there for Mathematica. Online solvers are there like for derivative, integration, and differential equations, and addition, matrix, something else. Okay, there are some online solvers are there for Mathematica. Okay, in between you, if you want, you can use those online solvers. Okay, now okay, this is useful for teaching as well as research. Okay, suppose here in SIT we are using MATLAB to solve to program the problems which we discussed in the numerical methods. Okay, one can use Mathematica also. Okay, if we are using Mathematica, there is no need of MATLAB, because here MATLAB is a nice software, but from that we will write some lengthy programming. Suppose here if we want to write a program, even in C also, if you write a program for bisection method, so we need to define all the parameters. Z is equal to, means C is equal to A plus B by 2. Then next iteration. Like that, we write many lengthy programs in C, C++, and MATLAB. But here there is no need of writing any code. Simply we have to give the equation directly. Okay, if you want to give the method name, okay, the plus point of Mathematica is almost all the numerical methods or numerical techniques are inbuilt functions in Mathematica. Okay, for lengthy programs we use in MATLAB, C, and so on, but there is no need of any programming here. Okay, simply it is a symbolic computation. Now, actually, it was created by Wolfram. It was created by Wolfram in 1988. In 1988. And here Wolfram is a programming language which will be used in Mathematica. It is a programming language. This is used in Mathematica. Okay, many links are available here. Generally, many links are available to convert to exchange Mathematica origin, R, and so on equations. Okay, there are many tools are available. Suppose if we are writing here in MATLAB or Mathematica or something else, so tools are available to convert from R to Mathematica, Mathematica to MATLAB, so on. Okay, generally, suppose we are running the program in C, and we are running program in MATLAB, and we are running programming Mathematica. Okay, the file name should be different. So whenever we are saving this Mathematica, the file name should be .nb. The file name should be .nb. In MATLAB, that should be .m files, program files, and in C, what is that? What is the file name in C? Dot. Anybody?
.c or .cpp.
.c or .cpp. Thank you. Okay, like this we can save the files. Now to start Mathematica, there are actually it is a Mathematica is a case sensitive. Case sensitive. Generally, mostly we use only three brackets. Three brackets. Okay, and here first one is parenthesis. First one is parenthesis. Second one is braces. Third one is square bracket. Parenthesis, braces, square brackets. Okay, parenthesis is used for grouping the expression. Grouping the expressions. Grouping the expressions. Suppose means here, suppose I want to find 1 plus 2 by 2 or 1 plus 2 by 3. So I need to group these items 1 plus 2. So simply I need to write 1 plus 2 by 2 in a bracket. Okay, that is in the parenthesis. Okay, like this kind of things we use the parenthesis. Okay, grouping the expressions. Now coming to braces. Okay, if you want to write a list, some range or domains. Okay, in this case we use braces like some list. Okay, the variables are in x comma y, that is in parenthesis. Our x range is 0 to 2. This is in braces. Okay, braces are useful to write a list, range, or domain. Now square brackets are useful in the function arguments. Function arguments. Function arguments means, suppose if you want to find f of x, if you write f of x, okay, that f of x we use in terms of square brackets. Okay, these are the main three brackets. Okay, suppose in place of parenthesis, if you write a brace or a square bracket, that will not works. Okay, parenthesis is useful for grouping the expressions. Braces are for list, range, or domain, and square brackets are for using functions. Okay, now here generally in MATLAB or something, MATLAB C or so on, I think those are also case sensitive. Here it is case sensitive. In each and every, suppose here we are writing some start or clear all, or we use some symbols alpha so on. The first letter should be capital in the MATLAB always. Suppose here we need to clear some item. Clear in a square bracket, some whatever the item is there, suppose A is there, we need to clear A. So the first letter should be capital in everywhere, not only in here, everywhere. Whatever we are using the like in wording, always first letter should be capital. Okay, now uh, to run here, suppose here if you have if you are running the program, to run the program is we need to enter shift plus control, sorry, shift plus enter. Okay, we need to use shift plus enter to evaluate the cells. We need to use shift plus enter to evaluate the cells, and this is for evaluate. and control plus L. Control plus L is copied down input line. Copied down input line. Control L will be useful for copied down input line, and control plus shift plus L copy down the output line. Copy down the output line. Okay, shift plus enter is evaluate the cells. Control plus L is copy the input line, and control plus shift plus L is copy the output line. Generally, you see, this is the mathematical window. Okay, this is a taskbar. Top of the window is here taskbar. Okay, this one is uh, input window, and some symbols will be there, like this is called pellet, means here which is a combination of all the expressions, mathematical expressions, whatever they are having. Okay, directly we can use if you want. Okay, this is looks like Mathematica, and suppose we are having, suppose I'm writing 2, sorry, 2 plus 3, 2 plus 3, it will give us direct result. For finding the result, what we need to do means to evaluate the cell, what we need to do, shift enter. Simply press shift and enter, the result is 5. So 2 plus 3 is 5. You see here, this is input line, 2 plus 3, and this 5 is output line. And you see here, there are in the right side of that line, okay, there are two brackets, smaller brackets are there. So first smaller bracket is for input line, input command, and second bracket is for output command, and there is a big bracket is there, that is for entirely the process of input and output line. Okay, now suppose here, if you want to use some symbols, like mathematics symbols, alpha, beta, gamma, so on. Okay, as usually I said here, all the symbols can be write in terms of in terms of some wording. In that wording, first letter should be capital. Okay, suppose I want to write alpha. Okay, simply no need to do anything, simply backslash and write a square bracket, then alpha. Okay, alpha we need to mention alpha, directly alpha came. Suppose I need to write beta, backslash beta, sorry, okay, beta. Okay, like this, alpha, beta, whatever the symbols are there, okay, we need to write backslash in the square bracket, whatever the wording is there for that symbol. Suppose I need to write mu. Okay, each and every item is there like this. Okay, otherwise also you can use the symbols. Pellet is there. Here pellet is there. You can use the symbols here. I think the symbols are there available. Okay, all the symbols are available. If it is not there, then we can use that thing. Okay, almost all the symbols are there. If it is not there, we can use like this. Then suppose we are using like subtract, addition, multiplication, division, and power. Okay, MATLAB also we can use. First, as usual, for subtraction we use minus. Here also minus. For addition, plus. Here also plus. Already I used here plus here. 2 plus I have used here for addition. And for division, slash. For division we use slash, and power we use cap. In MATLAB also we use cap, and for multiplication star. Here also we use star. Okay. Now suppose here if you want to write some few commands like 2 power n, or x subscript something, and square root of something, and how to define the divisions, so on. Okay, in shortcut form means in shortcut form without using palette. Okay, if you are using palette there is no problem. Okay, without using palette, suppose I need to write x square. I need to write x square. What I do? X control cap 2 x square, control cap 2. Okay, that is x square. Similarly, suppose x subscript some k, x x control dash or minus some k, subscript k. Now suppose if you want to write root, so control 2x, simply control 2x, control 2x, root x. Suppose if you want to write division x by y, or divides y, so for x by x upon y we use x control backslash, x control backslash y, x control backslash y, and nth root of x. Suppose if I want to write nth root of x, the control 2x, suppose I will write control 2, control 2, control percentage, then n. Okay, nth root of 2. Okay, like this you can use. With the help of keyboard we write anything like in the mathematical symbols without using any palette. Okay, now suppose there are some matrices, or like some simple expressions are there. Suppose there are two, so there are few differences. There are few differences here. Suppose if I write generally in the notebook we write suppose for multiplication we write AB, means A into B generally, that is. Okay, so mostly we don't prefer to write multiplication into or something else. Okay, suppose if I write AB, AB in Mathematica, it will take as a variable. In Mathematica, it will be take as a variable. A is some 2 or B, A is equal to 2 or B is equal to 3 something. Let us check here how it works. Suppose A is equal to 2, I am writing. A is equal to 2, I am writing. And moreover, semicolon gives us, suppresses the result. Suppose if we write the semicolon for each and everything, then you can evaluate the cell, that will not run. That will not run. Okay, after for final outcome, whatever the outcome for suppose we are running some last command. For that command, no need, don't mention semicolon. If you mention semicolon, that will not give the result. Okay, B is equal to suppose 3. Okay, I have given A plus B. Then I will write AB, simply AB. There is no space, there is no multiplication, no place, no subtraction, something else. Okay, now I am running. You see, nothing is there. AB means AB only. Okay, suppose if I write A space B, you see how what happens here. Is it visible the screen?
Yes, sir.
Yeah, thank
Yes,
you.
sir.
Yeah, thank you.
Yes, sir.
Yeah. Suppose A space B I have written. My A is 2 and B is 3. So A space B, what will happen? You see, answer is 6. So multiplication means here space denotes like multiplication. Either you can write A star B also. There is no problem. A star B. A star B. You see what happens? Result is same. Means in place of star we may use space also. There is no problem in Mathematica. Suppose I write 2 into 3, 2 space 3 directly. You see, I have given space, but in between multiplication symbol is came automatically. Space defines as a multiplication. So shift enter, the result is 6. Suppose if I write 2a, 2a, a is defined, predefined, a is 2. My a is 2 here. So shift enter 4. But if I write a2, if I write a2, it is simply a variable a2. 2a gives us 2 into a, but a2 gives us not 2a into 2. That is a2 gives us simply a variable. If I run that thing, a2 gives only. We don't get any result for that. Means a space b gives us and multiplication, and a star b gives us also multiplication. And to something a is defined something earlier. So 2a gives us result and a2 gives us not a result, that is a simply variable. Now moreover there are history. If you want to use the history sometimes in the programming, in the research, suppose if you are doing research, suppose here you're writing some programs, you need to use some particular outcome or particular output or particular input. For that, simply we use percentage, double percentage, so on. Suppose if I write percentage, you see what happens. Percentage simply shift enter. What is this? Only 1% sign gives us the last output. You see, the last output was A2. The last output was A2. That's why it is A2. It is A2. Means percentage gives us last output. Suppose if you write 2 times percentage, means the last but one output. 3% 3% signs are there. The last but two outputs. Suppose if I write 4 5 percentage signs, we'll see what happens. Is AB. You see, I think that came here. This one, fifth one. 1 2 3 4 5 something. This one that came. Okay, how many percent is given? 1 2 3 4 5 6 7. Sorry, 7. 1 2 3 4 5 6 7. So seventh output is this one. Because 7 times percentage I have written. So seventh output came as a result like this. Suppose here we have hundreds of inputs and outputs are there, but we don't do. Suppose we need a second output or third output. We don't mention 99%, 99 times of percentages. Okay, this is 1 or 2 or 3. There is no problem. But suppose hundreds of we need to go first output or second output or third output. We don't mention this 100 times percentage symbol. So simply there is a one more word to use this particular outcome, that is out of some number. Suppose I want to see the outcome of 17. This is outcome of 17 6. You see, I'm writing outcome of 17. Outcome of 17. Let's run 6. You see here 17th outcome is 6. You see outcome of 17th is 6. Like that we can use the outcomes wherever we want. Similarly, Similarly, for inputs also, input lines also we can use here. The command for that is in off, whatever the input command. Suppose if I am giving 19th input, done. Okay, directly the result came here. 24th input is 6. So 19th input is 6. Like that we can use the input and output commands. Similarly, we need to square multiplication something else by using outcome of 17th or 19th or so on. Suppose I need to find the square of outcome of 17. Square of outcome of 17. Simply what we do, outcome of sorry, first letter should be capital, other letter should be small. Outcome of 17th. Outcome of 17. I need to find the square for this. Suppose, okay, simply shift power 2. What is our outcome? Outcome of 17 is, I think so, 6. So answer is 36. Like this also we can use. Okay, now we are going for simple calculations. Now already we have seen how to use the addition and how to use the multiplication, so on. So I will start again here. Generally, suppose if we want to find 3 plus 4, simply we write 3 plus 4. 3 plus 4. To use 7. I am not using 7 plus something. Okay, simply I use the outcome of this thing plus addition, subtraction, multiplication or something else. Okay, then it is percentage means last outcome plus 6, suppose plus 6 power or something else, whatever that is. Plus 6 I am using here. So shift enter. So 13. Percentage means 7, last outcome. That is 7 plus 6 is 13. Then suppose here one more thing I want to write here. Suppose I write here 16 division. 16 division 7 28. Suppose I am writing this one and shift enter. I got 2 by 91. 2 by 91. Okay, means here it is not evaluated fully. Means here it is given a simple expression 2 by 19. But if you want to find numerate for this, okay, what we find, simply there is a command numerate of n of 2 by 91, or if you want, you can write 16 by 278 also, 2 by 91. Then shift enter. You see the answer is 0.021978.
We are not able to see your screen.
Okay, sorry, once
Share
again I
your
will share.
time.
Yeah, once again I will share. Is it visible now? Hello.
Yes, sir.
Is it visible?
Yes, it is.
Yeah, thank you. Now to find numerical value here, n of 2 by 91, so 0.021978 numerical value. Suppose I don't want to use n of something. Simply what we do here, simply uh, 2 point or 2.91. 2.91. It gives us a shift enter. Then you see the value, that value and this value are same. Okay, suppose if you want to find, sometimes you need more decimal places. sometimes you need more decimal places. In that case, what you do, numerate of 2 by 91, 2 by 91. Suppose you need 100 decimal places, 100 decimal places after that. So shift enter, you'll get 100 decimal places. Okay, like this, you will get the results. Now, suppose you see one more thing is 3 cap means power 1000. If I want to write evaluating, the value is this thing. 3 power 1000 value is this thing directly. Now, in the suppose if you are using this thing in research area, it is not better to use this much values. Okay, ऐसा लिखेंगे तो एक पेज में एक एक्सप्रेशन में खत्म हो जाएगा. But we don't use this thing. Okay, for that reason, one more command is there. 3 dot top same 1000 I'm writing. You see what is the result for that? Simple expression. Okay, the value is 1.322 something into 10 power 477. So simply we can use this thing. Okay, for simplified results also we can use this dot. Similarly, you see one more thing, square root of something. Suppose if I want to write square root of something, SQRT. SQRT is used for square root. Square root of 2 I am writing. I'm not doing anything. Square root of 2 and shift enter. Then root of 2. That is expression is came. But I need the value of that. So what I do? Simply SQRT of 2 dot. 2 dot. You see what happens? The result came. Okay, like this we can use the dot. And similarly, we used here 2 by 91 or like 16 by 728, so on. Okay, for division, we use divide symbol, divide wording also. You see how it works. Divide, divide of 8 comma 9, 8 comma 9. Okay, you can use this symbol also to represent. And plus addition also, plus of 8 comma 9 means 8 plus 9 you will get, times of 8 comma 9 means 8 into 9 you will get. Okay, like the values. And suppose if you want to find some integer digits in your research, suppose there is a lengthy numerator, numerical value is there, like 1 to 100 values are there. So how to define the integers? Here's the point. For that, what we do? Integer digits. Integer digits. Suppose I'm having what 1, 2, 3, 4, 5. Okay, what are the integer digits in this number? So simply we write integer digits 1, 2, 3, 4, 5. Then shift enter. Then you see the integers are in the number 1, 2, 3, 4, 5. Suppose if we want to find the tuples of same integer digits, suppose if you take same or others, so I want to use tuples of integer digits of same thing. I'm copying, copy, or we can use that command also, input of that command. There is no problem. Copy 3 I'm writing. Let's see what happens here. All the tuples came here within 1, 2, 3, 4, 5. So these are the tuples. Okay, like suppose I want to find some factorial. Simply either you can use the Palette or you can use the symbolic form. Simply factorial of 12. Suppose if you want to write, the bracket must be a square, otherwise it will not works. Okay, factorial of 12. Shift enter. The answer is that. Then there are a few head, floor, ceiling, round values also there. And suppose you see here what happens here. I'm writing head of 4 by 2. I'm writing 4 by 2. So you see the value is integer. The behavior is here integer. Head of 4 by 2 is integer. 4 by 2 is 2. 2 is an integer. Okay, now similarly floor I'm writing here. You see floor. It gives us floor value. It gives us floor value. If I write 5 by 2, 5 by 2 gives us 2.5. But floor value for this is 2. Floor value is 2. 2.5 का floor value क्या है 2 है. Similarly we can get ceiling value. So for ceiling value, ceiling of 5 by 2, same 5 by 2 I'm writing 5 by 2. So shift enter. So you see 2.5 ceiling value is 3. Similarly we can round it off. Round of 5 by 2, same value I'm using. According to the mathematical choice, it will round up to either 2 or 3 based on the situation. Then suppose here for data analytics use sample data. So for that suppose I need random integers in between so and so. So you see how to create the random integers. So I'm giving some name unsorted equal. This is my name. Unsorted is my name. Okay. Random integer. I need random integers between 100 minus 100 to minus 100 comma 100 means minus 100 to 100. I need 50 digits. How many digits I need? 50 digits. Sorry, 50 integers. Okay. Now enter. You see these are the 50 integers. So these are from minus 100 to 100 randomly. Suppose if you write, you will get different values. This is the random integers. Okay, these are not in the order wise, either in decreasing or increasing. Okay, this is a these are the unsorted integers. So I need to sort these variables or sort these values. Simply what I need to do? Simply sort of. I have given the name for this, that is unsorted. So I'm copying that thing, unsorted. Sort of unsorted gives us. Okay, it came now order wise. Okay, like this we use basic mathematics. Now already we defined here a is equal to b and a is equal to 2 or b is equal to 3, like that kind of things. Already that is covered. Now I am defining here how to solve the some equation. How to solve the equation. Okay, you see, solve. Okay, I'm giving small example here. Okay, later we'll discuss more on this. Solve. Okay, suppose I'm having 3y is equal to 3y plus 12, 3y plus 12 is equal to 0, comma y. Comma y means we need to solve for y. Means we need to find y. Okay, if I run this, I don't get the result. There is an error. Okay, whenever we are using solve or whenever we are using the equations, okay, in the equation there should be two equal signs. Okay, 3y plus 12 equal 0. Then now if I run this, the answer is y is equal to minus 4. Directly the result came 3y plus 12 is equal to 0, then 3y is equal to minus 12, y is equal to minus 4. So like this we can get the results for equations. Similarly, till now we used parentheses, we used and curly braces we used, and we have not used the functions. We have not used the functions. Okay, now I am going to use the functions now. F of, you see, square bracket x. Okay, we need to use underscore to define the functions. Okay, f of x is equal to, suppose my function is x square, x square, x cap square. This is my function f of x. Suppose if I want to find f of 2 or f of 3, f of 4, simply what we do, f of 2 square bracket f of 4 if I want, so enter 16. F of 4 means 4 square means 16. Okay, this is function of one variable. Suppose function of two variables are there. Function of two variables are there. Then in that case, same thing, I'm using different function g square bracket x underscore comma y underscore, x underscore comma y underscore. Now I'm defining this function as x cap by x power y, x power y. Okay, now I need to find a g of 2 comma 3, g of 2 comma 3. 2 comma 3 means x is equal to 2 and y is equal to 3. So the expected result will be 8. Is 2 power 3. 2 power 3 value is 8. So like this we can find we can use the square brackets for functions, either that is in a single valued function or multiple valued function. Now there are some list is there. Suppose I am defining the list as x is equal to, okay, already I said here list. Okay, that is in braces. Okay, I am writing 10 comma 11 comma 12 comma 13 comma 14 comma 15. Okay, this is my list. Now I need to use some values. Okay, in many research areas we use some particular values. Okay, either we can use 10 or 12 or 15. In between that list I need to use some values. So in that case there are a few commands for that. You see, if I want to use 10 is first in the list, so simply what we write, first first, first in the list x. What is my, that is I think capital. First in the list x, enter. First value is 10. Suppose if I want to use last, simply use last in last of x is capital, so last of x, that is 15. Suppose in between part of suppose if I want to use 11 or 12, okay, that is we can use the for that part. So part of x comma Which one value? Suppose second one for first or second or third. Based on that, we need to give the number. Suppose I am writing 3. I'm x comma 3. I'm writing. Shift enter. So that is 12. Means third number. First one is 10. Second one is 12. 11. Third one is 12. So third number in x is 12. Like that. Suppose if I want to use in between more than one digit. In that case, what we do? X of uh, 3 to 4 I'm using. 3 to 5 I'm using. Suppose 3 comma third value, fourth value, and fifth value I'm using. Okay, shift enter. Okay, there was some error in this case. Let's see later. We'll see here. Okay, that needs to come here 12, 13, 14. Okay. Let's see some other commands we see. Meanwhile, range of. Suppose if I write range of 5. The range of 5. If I write, you see, the range of 5 is 1, 2, 3, 4, 5. Similarly, the range of 5 to 10 I need. The range of 5 to 10 I need. So for that, the command is range of 5 comma 10. 5 comma 10. Okay, shift enter. 5 to 10. Similarly, suppose here I need the range. I need the range in between 5 and 10, but with specific range, specific distance, specific length. So for that, what we do? Same range of I will use 5 to 10, 11 or 5 to 10, whatever you want. You can take 5 comma 20 comma. I need the distance step size is 2 or 3. 3. You see, shift enter. You see 5, 8, 11, 14, 13, 17, 20. Step size is 3 for each and every integer. Now we need to find the factorials from 1 to 5 or 1 to 10 or 1 to 1000, so on. So for that we use command table of some x factorial. Okay, factorial of x, my range I need from you see I'm writing n comma 5. Let's see what happens. Sorry, this should be 1 comma 5. 1 to 5. There is no n, that's why. Table of x factorial 1 comma 5. Or we can use yeah, table of factorial x comma 1 comma 5. Okay, that gives us the factorial value of x from 1 to 5. So 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, like that. So the table useful for like this kind of situations. Similarly, suppose if I want to find x square from 1 to 5 or 1 to 10 or 1 to 100. So you see, copy paste. You see table in place of factorial x, I am writing x square or x cube, whatever that is, x power 3. I want to find 50, 1 to 50 x cubes. So shift enter. So these are the x cubes from 1 to 50. Okay. Now, okay, don't confuse here. There are many topics are there. Simply I'm giving 1 or 2 examples for each. Okay, make you understand how we are using the Mathematica. Okay, till now we have discussed addition, multiplication, and range, parts, and all the brackets like parentheses, square brackets, and braces, everything. Now we are going to use some expressions. Suppose there are some expressions are there like hello,
Hello.
Haji. Any doubt?
Sir, can you increase the font size?
Yeah. Okay, is it fine?
Uh, Little bit more.
Is it?
Okay, thank you. Thank you, sir.
Yeah. Now suppose here we have some functions like x plus 1 into x plus 2. We need to expand that thing. Simply what we use for that? Simply expand of x plus 1 into x plus 2 into x plus 2. I need to expand this thing. Okay, simply write this, shift enter. That gives us expansion of that x plus 1 and x plus 2. Okay, Mathematica is very useful for researchers. Okay, mostly what we suppose here in mathematics or mechanical or electronics also, there are some equations. Simply equations are there. The solution they will write in only single sentence. The solutions have calculated through Mathematica. Okay, their publications are in Q1, Q2 journals. Even my 2 research papers also in Q1 journals. Simply we used Mathematica to solve the systems. Okay, no need to write anything. Simply the equations are solved using Mathematica. That's it. And accordingly we will get the graphs, plottings. Okay. Nowadays researchers are widely using this Mathematica. Now, okay, going for topic. Now here the expand is useful for expanding that expressions. And similarly, there are many topics are there like factor. Suppose I'm using this expression, I need to write in terms of factors. So you see how to write factor of I'm writing x square plus 3x2 x square x cap 2 x square plus 3x plus 2. Shift enter. Okay, you see 1 plus x into 2 plus x. Okay, suppose here if you are having different things like in partial fractions, we will having some a upon x plus 1 plus b upon x plus 2. Suppose if you want to write together, for that there is a command simply together of 2 upon x plus 2 x plus 2 minus 1 upon x minus x plus 1 1 upon Like we can take x minus or x plus 1, x plus 1. Then we see what happens. See, there's a combination of those things, means simplified version, x upon 1 plus x into 2 plus x. Then similarly we can use simplify and full simplify and so on. Okay, now here there is one more thing is there to discuss with functions. Suppose I'm having some function x cube plus 6x square plus 11x plus 6. That is my function, suppose. Okay, you see, for that I'm using here, I'm not defining any function name for that. Directly I'm using part of x cube plus 6 x square 6x square plus 11x plus 7 plus 7. Okay, in this thing I need 1. You see, I'm writing 1. What happens, you will see here. I'm using 2. Okay, 1 I'm writing. So you see, shift enter. What was the result here? 7. Means here last term we got. Similarly, if you write 2, 11x. If you write 3, third one. It means here nth term you are getting here. Okay, first term, second term, third term, fourth term, fifth term, like that. Suppose if you are writing 4, 2x cube. Okay, suppose here if you want to write the coefficients of x, quotient of y, or quotient of quotient of x square, x cube, so on. Okay, now for that, you see what we need to mention for that, coefficient list. Coefficient list, same expression I'm using. Copy, paste. Okay, I need the quotient of x. Quotient of x. The quotient of x. Sorry. So this is not quotient. This is a quotient list. Sorry. For quotient, simply write only quotient. Write only quotient. Quotient of x is 11. And for quotient of x square, if I want 6, like this, you can find the coefficients and first term, second term, third term, so on. And quotient list also already we have seen. Now, suppose like here we are having some numerator and we are having some denominator. We are having some numerator and we are having some denominator. Okay. Now in this case, suppose we need to find the numerator. Simply we write the numerator. You see here what I'm writing. Numerator of outcome of 67. I'm writing 67. Outcome is x upon 1 plus x into 2 plus x. So I'm using outcome of that thing directly. Outcome of 67. See, it will give the result or not. Yes. Numerator of outcome of 67 is x. Similarly, I need to find the denominator for the same. Denominator of outcome of 67. Same outcome of 67 I'm using. Outcome of 67. Let's see. Outcome of 67 is, you see, 67 outcome is x upon 1 plus x into 2 plus x. So denominator is 1 plus x into 2 plus x. So 1 plus x into 2 plus x. Like this, we can specify, or we can use a particular numerator or denominator. Okay, till now we have discussed the basic idea of Mathematica, how this will works. But we have not started Mathematica till now. Simply, we have studied till now how the Mathematica works for addition, multiplication, so on. How to use the Mathematica in terms in functions, and how to use how to get the coefficients and values, so on. Okay. Now we are going to solve. We are going to solve some equations, and we go for differentiation, we go for integration, then we go for matrices, then we go for differential equations, and we go for plotting. Okay, plotting is very important, and differential equations also useful for you. Okay, somewhere. Okay, now I'm going to find the solutions of equations. Solutions of equations. Now, suppose if I want to find the solution, or okay, we need to use the solve command only. Solve x cube minus 6 x square plus 11x minus 6 is equal to, you see, we are using solve. So double equal is equal to 0. We are solving for x. So comma x. So simply shift enter. The result is x is equal to 1, x is equal to 2, x is equal to 3. Means x is equal to 1 comma 2 comma 3. Cubic equation, so that we are having 3 values. Okay. Now please try to use Google to solve this same equation. Okay, what you write here in the Google, Mathematica equation solver. Mathematica equation solver. Equation solver online. Okay. Now write the equation, whatever you want. Please write the equation here. Then please tell me the result. The same equation. Okay. What you type in the Google, Mathematica solver, Mathematica equation solver. So you'll get this thing. So simply what you need to write? You write the equation only. With that gives each and everything, but we need the solution only. The solution also we will get. Okay, same equation I'm typing here. Copy. You see, the result came here. Same equation I have used. That is given here. The graphical representation also. Then a simplified version also they have given. that can be written as x minus 3 into x minus 2 into x minus 1 is equal to 0. Then again simplified.
तिला पडतात माझे पण पडतात.
Hello. Hello. Any doubt?
No sir.
Yeah. Okay, please use. Okay, please type. Are you getting or not? Please tell me. You can use any equation, not only this, any equation you can use.
Sir, we can use the Symbolab also, right, to solve the equations accordingly.
Sorry, what is the question?
Instead of Wolfram alpha, we can use the Symbolab also, right?
Symbol also, there is no problem. Yeah.
Yeah. Because that is much easier than the Wolfram alpha. I am using it currently. That's why.
Yeah.
Okay.
Yeah. Okay, this is for single equation. Please try. Are you trying or shall I continue?
Yes, sir. We got it.
Okay, thank you. Next one is suppose we are having simultaneous equation. Two equations are there. We need to solve for x and y. Okay, for that, you can use in simultaneous equations also mathematical solver. You may get solve. I'm using two equations. That is x square plus y square. Okay, 2 times equal 2. Here in between we need to use and. In between we need to use and x minus y is equal to 0. We need to solve for x and y. Okay, that we need to write in terms of braces because that is some list x comma y. So let's see what happens. Shift enter. You see there are two solutions, x is equal to -1 and y is equal to -1, and x is equal to 1 and y is equal to 1. Okay, like this we can use the equations. Suppose here for each and every equation we don't get the analytical solution. We are getting analytical solution, then there is no problem. But always we cannot get the analytical solution. Okay, in that case we are going to find numerical method, numerical solution. Already I think you must have studied bisection method, regular fallacy method, Newton-Raphson method, and okay, and many other. Okay, maybe Gauss-Seidel or sorry, that is a different thing. Okay, now for that numerical method, we need to use n-solve, numerical solve. N stands for numerical, S stands for solver. Okay, numerical solver, n-solve. So n solve, n s should be capital. N solve of whatever the equation, x power 5 minus 2x plus 3 is equal to 0. We are solving for x. Simply shift enter. Your result is this thing or this thing or this thing or this thing or this thing. So this is about numerical solver. Okay, as per the mathematical choice, it will choose either any method. If you want, we can define the method. If you want, we can define the method. Those topics we will discuss later. Okay, directly we can get the things like this. Suppose here there are complex numbers are given. So in the solution, the complex numbers also came here. I don't want those complex numbers. Okay, simply copy, paste x comma reals. Let us check. One, no, reals. Yeah. Okay, and solve. So it will give us only real root. Okay, without if we don't write reals, then it gives us all the roots. Means that may be real or complex. So if you write real only reals, then we will get the real roots. Similarly, numerical solve for simultaneous equations. So one more thing, in solve for simultaneous equations. Okay, in simultaneous equations, okay, earlier also we need to put brackets. Actually, that will be better to write in terms of braces. X square plus y cube plus y cube is equal to 1 comma. Okay, either you can use this thing or and symbol. There is no problem. Uh, it is better way to express 2x plus 3y is equal to 4. This is my equation, two equations, and comma. I need to solve for x and y. X comma y. So shift enter. Let's see. The result is came. Okay, if you want to find, we can use for reals. Okay, like this we can solve the algebraic and transcendental equations. Now suppose if we want to okay, if you want to find, we can use the root also, root of something that gives us a solution. Okay, next this is about the solution. Now we are going for differentiation. Now we are going for differentiation. Please let me know if you want some break.
Excuse me, sir.
Yeah.
Sir, in line number 82, we are getting two values for x, is it?
Yeah, we are getting two values. Not here we are getting x value is this thing and y value is this thing. These are simultaneous
And
equations.
in second bracket?
That is complex, means there are many solutions are there for the system.
Okay.
So possible solutions are 3. That's why they have given 3.
So only three possible solutions are there. That's why 3 pairs.
Yeah.
Is it like that? Okay.
Yeah. Okay, do you need break or should I continue?
Hi, sir. Hello.
Hello.
So can we solve this in this online tool also?
Yeah, you can solve. You can solve. Please try.
Okay. So same way we need to put after one equation we need to put and or comma.
No, in online solver directly they are having some symbols like this. You see here whenever you see this thing. Okay, you will get how to type here. Okay, they will give some instructions which equation you need to write where and there. Okay, this they will give some instructions here itself. What you need to type like that.
Okay, sir. Okay.
Yeah. There you no need to mention and because here x and y both are we need to solve. So that is predefined there in online solver. So we need to write the two equations, comma. I think we will use comma there. I think so.
Can you show the one example, sir? So it will help us.
Yeah, the solver is different in this case. Let's see. Let's try the simultaneous equation. Hey, can I? Mathematica.
सर
हाँ जी.
सेम इसमें वर्क हो रहा है सर.
हेलो.
हेलो.
हाँ जी, बोलिए.
Where we have solved the equations, we can also solve the simultaneous, I think. Hello.
You maybe other thing is also there here. There are four equations. You type here, then you compute. That's it. You will get. Yeah, there may be also there. I don't know. Have you tried?
Yes, sir. The previous example.
Yeah. Okay, if it is working, then nice. Otherwise, also there is other way is also there. Here, you try here online system of equation solver. So there are four equation limit is there. You write those four equations, then compute. Okay, there are many. Please try to try search in the web. Then you will get many other things. Definitely, you'll get somewhere.
Okay, sir. Okay, thank you.
Yeah. Okay, next we go for differentiation. Okay, for differentiation we use suppose if you want to find some derivatives are there. If you want to find dy by dx or df by dx, okay, this can be evaluated in Mathematica as d of f comma x. Suppose if you want to find d square f by dx square is equal to d of f comma x range is last 2. D square f by dx square can be written as d of f comma in the braces x comma 2. Suppose if you want to find a d cube f by dx cube, simply what you need to write d, whatever the f function is there, x comma 3, that's it. If it is increasing, then here the number will change. In this case the number is changed. Only single integral, there is no problem. If d of x f of f comma x, if d square f by dx square, then that should be in the braces x comma 2, d cube f by dx cube, so x comma 3. This is the way to write in Mathematica. And suppose if it is in partial differentiation, partial differentiation, so suppose if you want to find dou f by dou x dou y, simply same thing, d of f comma x comma y, dou f by dou x dou y is d of f comma x comma y. Suppose I don't know, you few people can read it as del, do, and something else. Okay, I'm using do, don't confuse. Okay, if you want, I can read it as del f by del x del y, sorry, del x square del y is equal to, suppose if I want to calculate this thing, I will use for this as d of, same concept here I apply. You see f comma, you see a del x square, so in the bracket x comma 2, x comma 2 del x square. Now there is no power for y, so simply y. Suppose here, sorry, here del cube, here del square. Now del power 4, so del power 5, suppose del power 5 f by del x square del y cube. Simply what I need to type, d of derivative of f comma x का power है 2a, so x comma 2, then y का power 3a, so y comma 3. Like this we can find the derivatives of ordinary as well as partial. Okay, let us try in Mathematica. Okay, I'm using function as I will define the functions, otherwise you can define, or no need to define, otherwise you can write as it is directly, otherwise you can call it if we write first. Okay, I'm writing directly. So d of my function is 3x power 4, 3x power 4. It is your wish. If you want, you can predefine, otherwise write directly, no problem. D 3x power 4 comma x. Sorry, it is came as capital. You see, differentiation is 12 x cube df by dx. Suppose if I want to find d square f by dx square. So in that case, what I need to do, simply no need to do anything, simply I need to add a curly brace here, curly brace x comma 2 d square f by dx square. That's it. Then I will get the differential second derivative of that, 36 x square. Similarly, if I want to find the trigonometric functions, simply what we need to do, same. Suppose df by dx, my f is trigonometric functions, derivative of sine of x, it should be case sensitive, the sine s should be capital, sine of x plus cos of x is my function, cos of x, or you can take 2x or 3x, whatever that is. If you want, you can take only 2x, there is no problem. And comma x. So this is your df by dx. Suppose I need to find a 10th derivative of this, or 100th derivative of this, 1000th derivative of this. Okay, simply what I need to do, copy, paste. Okay, I need to define the nth derivative. My nth derivative is n is my 400. Suppose is d power 400 by d x power 400. Answer is this thing. Okay, like this we can define nth derivative of any. Okay, now coming to partial derivatives. F of Okay, please try to solve derivatives. Okay, online mathematical solver is there. Please try to solve. Use Mathematica derivative solver. Mathematical solver for derivative. For derivative. Okay, please use any function you can use. Please try to find the derivative here. Online derivative calculator is there, Mathematica. So use any function of your wish. Are you getting solution or not? Please let me know. Are you getting?
Sir, we have
Yes, sir.
tried d of this thing function.
Hello.
हेलो
हाँ जी बोलिए.
सर हमें यहाँ पे डेरिवेटिव फंक्शन लिखना है या डी ऑफ समथिंग
No,
फंक्शन.
only function. You need to write only function. There is no need to write a derivative of something. Only function you need to write.
Then it is not showing. I don't know. Okay, I will check.
Yeah.
It is working, sir.
Yeah, it will work because no, don't write any d of or derivative or something. So only write function. That's it. Yeah.
It is coming, sir. Answer is
Yeah.
coming.
Yeah. Thank you. This example is there here itself. X sine x square. X sine of x square. Derivative. Okay. The derivative of this is calculating. Yeah. You see the derivative is here. Derivative is here. X sine x square is sine x square plus 2x square cos x square. Okay, it will come. Please check. And this is about ordinary derivative. Similarly, we are finding partial derivatives. Okay, first of all, I am using the function providing complexity. My f of x is f of x is f of x underscore. Okay, to define the function, I need to use underscore.
Hello, sir. Your screen is not visible.
Not visible. Okay, sorry. Now is it visible?
Yes.
Yes, sir.
Yeah. Thank you. Now my function is x square x square upon 1 plus x square 1 plus x square 1 plus x square. Now this is I have defined the function. Now I need to find the dou means del f by del x. Del f by sorry. Okay, already we have discussed this thing function. Okay, previously we have not used function. Now we are using function. Now let us try. We will get or not. F dashed of x. F dashed of x directly. Okay, like this also we can find instead of using derivative d. The derivative of f dashed of x is this thing. Similarly, we can use f double dashed of x, f triple dashed of x, or in the derivative of x. Okay, if we use the function. Okay, if you want to find a simplify, you can simplify. Already we discussed earlier. Suppose it is in complex terms, we are getting the derivative. Okay, already we used to simplify something kind of things in earlier. Simplify something we have used here. So that simplify you can use here to more simplify that answer. Now, suppose this is first derivative 1 we means the prime we write, second derivative means 2 primes we write, third derivative 3 primes we write. But suppose if we want to find 100th derivative, okay, there we need to use d only. There we need to use d only. Let's take suppose if I write 100, that will work or not. Square, so that will not work. Okay, for that d of f of x, sorry, f of x means that function whatever we have defined f of x. Now I need to find a 100th derivative x comma 100 x comma 100. So this is your 100th derivative of that. Yeah. Okay, now like that we can find, suppose if it is partial derivative partial derivative if we are finding, so we need to have two variables in that.
Sir?
Hello
Sir,
Haji.
in line number 87, you have purposefully put underscore after x, f of x underscore.
Line number underscore to define the functions we need to put underscore, otherwise it will not read. Yeah.
Okay.
Yeah. Okay, now in the partial derivative, to find partial derivative in the function we need to have two variables. So that variables I'm defining, the function I'm defining here, x underscore comma y underscore.
The screen is not visible.
Sorry, there may be some network issue. Now is it visible?
Yes, sir.
Yeah, thank you. Now suppose my function is x plus y power 4. This is my function. Okay, g of x comma y is equal to x plus y whole power 4. I need to find the dou g by dou x dou y. Dou g by dou x dou y. So earlier I discussed here dou f by dou square f by dou x dou y. For that I need to use this thing, d of f comma x comma y. So for that d of g of x comma y. There we don't mention underscore. Here only for defining the function only we mention underscore. Otherwise we don't mention underscore. G of x comma y. G of x comma y comma x comma y. Differentiation with respect to x and y. So dou square g by dou x dou y. So let us check. You see, this is your answer. So dou f by dou x करेंगे तो dou square f by dou square g by dou x dou y. Whenever you are differentiating with respect to y, 4 into that thing x plus y whole cube, and again differentiating with respect to x, 12 into x plus y whole square, right? So dou square g by dou x dou y. Now suppose dou cube g by dou x square dou y. In that case, what we need to do, simply we need to write a braces here. Need to write a braces here with respect to 2 only. Then shift enter. Then 12 x plus y. Suppose dou power 4 by dou x square dou y square. Dou y square. So here comma 2. Comma 2. Shift enter. 24. Okay, like this we can use we can find the partial derivatives of any order. Of any order, that may be any function. Okay, please take a small break for 15 minutes. We will meet exactly at 11:15. Okay, do you need break or no need?
Yes, sir.
Yeah. Okay, take a small break. 11. Okay, 11:10 को मिलते हैं हमें. 11:10 exactly. Okay, 15 minutes of break. So
Yes.
after break we discuss integration, matrices, and plotting, differential equations, and vectors. Okay.
Okay, sir.
Yeah. Thank you, and we'll meet within 15 minutes. Okay, welcome back. Am I audible?
Yes, sir.
Yeah, thank you. Okay, last we have discussed ordinary and partial derivatives. Now we are going to discuss integration. Prajakta, are you there? Hello. Prajakta, are you there? Vishnu, any doubt?
No, sir.
Vishnu, any doubt?
No, sir.
Yeah, okay.
Sir, we got access from Wolfram for only 14 days, sir. If you want to give the assignment, sir, can you give it now, sir?
Yeah. After this class, I will give that as assignment. Means here, I think in the chat box I have seen now only. 14 days trial version is getting. Okay,
Yes,
that message.
sir. So we are getting 14 days trial version. So if you give me assignment, then we can proceed now, sir.
Yeah. By today only I will give that assignment. This is of 5 marks. Okay, assignment for
Okay,
Mathematica.
Okay, sir.
Okay, I will give today. Today or by tomorrow I will give you.
Okay,
And for linear algebra also, you need the assignment or a quiz.
Anyone, sir. Q assignment or quiz, anyone.
Okay, fine.
Assignment, sir.
But we can use online version also for Wolfram Cloud. Then there is no limitation.
But ma'am, for online there is a restriction.
Okay.
Okay, any kind you can use. Okay, either you can download the trial version, then you can continue with that. Okay, no issue.
Okay, sir. Thank you.
Yeah.
Hello.
Hello.
Actually, I am struggling to get this trial version, sir.
Hello.
Hello.
हाँ जी बोलिए.
Sir, I am struggling to get this download this trial version. I don't know why. This asking is a key license key.
No, if it is trial version, they don't ask key. I think you must have downloaded a different thing. I think so. The key is required for that.
Okay. Can
Please
you
check.
which need to download?
You see the link is given in the chat box. Please try to look into that link. Okay, you may get from this. Vishnu has given the link.
Okay. No, but I don't. It's not going further.
Okay, Vishnu, that is working or not? Vishnu Pant, are you there?
Hello.
Hello.
Yes, sir.
Yeah, Vishnu, you have given some link that is working or not?
Yes, sir. It's working, sir.
Vishnu, can you just show how to? I'm struggling, Vishnu.
Yes, please.
I'm struggling to get that free. Can you just show? Actually, I'm when I'm proceeding, it's showing we should have to license key.
So you need to log in. You have to create the ID, and again, and you have to verify from your Gmail account, and it will give it to 14 days trial.
Okay. I did
You have
that,
to,
but I don't know why it's not showing me.
yes, sir. So can I share the link if you want to see?
Yeah, Vishnu, once you share the screen, then he will know. Okay.
Yeah,
All
please.
others also know.
Okay, sir.
Vishnu, I think it is it possible to share the screen? How you have done?
Yes, sir. Okay, sir. I will share. Yes, the screen is visible.
Yeah, it's coming.
Hello.
Yes, yes.
Yeah, Vishnu, it is visible. Please,
Okay, yeah, sir. You have to go for the Wolfram, and you have to create like you by using Gmail account. You have to create your ID and you have to verify from your Gmail account like this. You have to verify, and you will get access for 14 dial. Then after clicking this, you will be on this page like this.
it's what we need to do is from starting. Means after
So,
clicking that
sir,
link,
nothing,
then
sir. By using site, you just log in and just verify that by using Gmail ID.
okay.
Only
You
Gmail
just
ID
create
work.
sign. Hello.
Only Gmail ID is work or any other.
Any other you can use.
Verify your account. Any account you have to verify. That's important. So you will be in
Sir,
the, you have to verify which version you want.
sir, but after the verification from Gmail, it will redirect it to different
Access
page.
for web, mobile. No, sir. After verification, you will be in this page like
No,
this.
I am not getting this page basically.
From
When I
Wolfram
am
ID, you can
verifying,
see Wolfram ID details. You want to update. Go to product and services.
Sir, this I also went for that, but this kind of page they are not showing for me.
Oh, okay, let me check. Okay, I will try. I will try. Uh, wait a minute. I'm sharing the screen. Okay, after clicking this thing, I got this thing sign. I think it is visible to you all.
yes, sir.
Yeah.
Yes.
Suppose if I write my Gmail ID, uh, I will write in Gmail ID. Continue. Then yeah. We need to direct sign in or Vishnu, direct, or we need to create something.
Yes, sir. You have to create.
Okay, we have to create direct. No need to sign.
Yes,
We have
you can sign with a different account, sir.
okay. Then create one.
Yes, sir. Create one.
Yeah.
Yeah, yes, sir. Yeah, this is the procedure which I did.
Yeah. Means directly you are getting like this link. Then what we need to do?
So you need to verify now.
Okay.
Go to your account to verify. Yes, sir. You have received the mail.
Yeah. Then I need to click this to access features. Solver, please verify the mail. And now where we need to go, Vishnu? Products and services.
Hello?
Your screen is
Sir,
not
verify.
Your screen is not.
Yeah, verified.
Yes, screen not visible, sir.
Okay, now verification. I got this window.
Go to the next, sir. Product and services.
Yeah. User portal.
Yeah.
I got same.
Yeah, same happen with us, sir. Also, sir. Same kind of portal.
Same thing happened with me, sir.
Sir, for me also same thing is happened.
Yeah.
True, sir. Sir, can I share the link?
Wait a minute. The same thing we are getting. Vishnu, please show me what you did.
Sir, we have to go to user portal.
User
Okay, sir, I
portal.
will share the link.
Sir, it's their link.
Sir, it's visible. Hello?
Sir, on that previous page only, products and services.
Sir, my screen visible?
Sir, in products and
Yeah.
services, go
Yeah,
to
so you
user
can
portal.
see from the portal, sir, I got this. Wolfram trial 14 days left.
Sir, it is at the down, go to user portal.
Okay, wait a minute.
Yeah.
And I get this one, sir.
In user portal, that downloadable installer is there.
Okay, actually, all are not getting. Actually, even I am also not getting.
So just scroll down.
No, that is whatever you are saying. That is Vishnu's.
Yes, sir.
Yeah. Then after getting this, Vishnu, what you did?
So after, sir, I just confirmed from my email ID and I got
Yes,
this one, sir.
yes, yes.
So
Then
you, sir,
Sir,
you
in,
just see email is verified or not, sir.
yes,
This should
that
be
is fine.
verified.
That is
sir,
fine.
in products and services, are you not getting user portal?
No,
This is I got,
I
but this
Go
got
is
to
not
only
user
this
user.
one.
portal. Go to user portal. That link, that red colored link is there now
And then
at the end.
directly I will be in this page.
Again, we are same process. Whatever we did, that page we got. Okay, there is no problem. Don't worry. At least use that online versions. Online solvers are there. So if you have downloaded and using trial version, then well and good. Otherwise, please use the solvers. No issue. Okay, few people are getting a problem because here I'm also getting problem in downloading and installing that thing. Okay, we'll start the lecture. You use the online version. Yeah, yeah. Okay, we'll start the lecture. Okay, if you are using trial version, then that is good. Otherwise, also we have online solvers. Please use those solvers. Okay, now we are going to discuss the integration part. So there are two kinds of integration. One is general integration, other one is numerical integration. Okay. Now, first one is general integration. We are discussing integration. So suppose if I want to find integration here also in general also we have two. One is definite integrals. Other one is indefinite integrals. Definite and indefinite. Okay. First of all, I'm discussing about indefinite integrals. So indefinite means here there is no limits, lower and upper limit. So if I want to find the integral f of x dx, this thing we need to write in Mathematica. That is simply integrate. Same letters we use integrate f of x comma x, f of x comma x. Simply there is no limit, so no need to write anything. Simply integrate f of x comma x. Now suppose there are some limits a to b. A is some number and b is some other number. So f of x dx. F of x may be anything, trigonometric or normal or in terms of complex function, anything. Okay. Now for this, here limits are a to b, so that integration or integrate f of x comma, we need to specify the x limits. So x limits are 0 to, sorry, a to b, a comma b, a comma b, integrate f of x a comma b. Whenever limits are there, earlier also we did like this. Okay, x comma a comma b. Okay, like this we can find. Similarly, suppose if it is about numerical integration, simply we add here n extra, n integrate of that function under the range of x. So this is a procedure to find the integration of any function, any kind of function, that may be any the complexity is anything. Okay, now go for we go for the method. Okay, we start this thing. Suppose my function is, sorry, I need to define a some function. I'm using a new page. F of x underscore. Okay, I'm defining the function f of x is equal to 1 upon my function is x square into exponential of exp, exponential of 1 upon x. This is my function. Okay, now I need to integrate this with respect to x. With respect to x, simply what I do, integrate okay, this is my integration with respect to x. Okay, now suppose if like this you can use anything. Suppose my function is 1 upon x square only. I'm removing this. Then integration of f of x with respect to x. My integration is this thing, minus 1 upon x. Like this, you can use any function of your wish. And similarly, suppose there are some limits. Then in that case, we use the numerical methods. Then that is maybe bisection method or regular fallacy method or Newton-Raphson method, anything. Okay, Mathematica automatically choose one of the method, this method. Otherwise, we can define the method. Okay, the plotting we will discuss how to define those methods generally. Here also same process we need to apply here. Now, suppose I'm having some other function. D, I'm taking the function as dx underscore is equal to x square into square root of 1 plus x square. SQRT, or we can use that parenthesis also. What is that? Control. We have used control for that. Control 2 1 plus x square, or you can use parenthesis also, there is no problem. 1 plus x square. This is my function I'm defining for g. So I need to find numerical integration for this from some range to from lower limit to upper limit. So the limit is let us take 1 to 2. So what I need to write? N integrate n and I should be capital. N integrate of my g of x. G is a function we are integrating. G of x comma I'm integrating with respect to x within some range. So in the braces x comma 1 to 4. My lower limit is 1 and upper limit is 4. Lower limit is 1 and upper limit is 4. So integrate. Then my answer is 67.3492. Okay, like this we can find, we use the numerical integration, and you can use any function. Suppose if you want to find if you want to use trigonometric functions, trigonometric functions. So your h, I'm defining h of x underscore is equal to, your function is x into cos of x square. Sorry, cos should be capital, c should be capital, cos of x square Okay, this is my function for the h of x. Then I need to integrate numerically from 0 to pi by 2. 0 to pi by 2. Okay. Now simply integrate, integrate. If you are using n means numerical integration, normal integration, integrate means only normal integration. Okay, n integrate of h of x, the range is, x range is x comma 0 comma pi by 2 or square root of pi by 2, pi by 2. Simply I'm using pi by 2. So shift enter. This is the answer in terms of numerical integration. Now I told you this is Mathematica automatically choose the method. Okay, we don't know which method that is using, but answer is giving. But suppose we want to use some particular method, means trapezoidal use करना है, Simpsons use करना है, कैसा है. So for that, what you need to do is, suppose we are having this inline 100. For this, you need to write a method. Which method you want to follow. Method implies which method you want to follow, that you need to mention here. Trapezoidal rule. Suppose trapezoidal rule. This method I need to use to evaluate this integration. So my result is this thing. Okay, similarly, Simpson's rule. You can use Simpson's rule here. Okay, from that you will get different solutions. Simpson's rule. Should built-in function, built-in method. There must be a typo error. Okay, like this here we use the method. Method implies the method name. Okay, accordingly you will get the solution. Okay, please look into this. There is some typo error. Simpson's rule, there may be hyphen something missed. Like that we need to write the method implies that method name. Okay, now we are going to discuss matrices. Suppose if I want to write matrix, suppose my matrix is M is equal to 1 2 3 4 5 6 7 8 9. I want to write this in terms of Mathematica. So what I do, simply M is equal to, or some expression is equal to, what I do, there are two ways. Either you can use that way or this way. Here the expression is here. Entirely we write in a braces. So each and every row you need to write. First row 1 comma 2 comma 3. This is your first row. Comma, that is in one brace. Second row 4 comma 5 comma 6. Second row. Next third row 7 comma 8 comma 9. Like this. Okay, after writing this we need to define M, means this M backslash 2 times, and a matrix form we need to write. A matrix form. Or if you are not comfortable with this, if you are not comfortable with this, you write here matrix form of square bracket, this thing. That is your wish. Okay, like this we can define the matrices in Mathematica. Like you see, let us check that works or not. Let us take I'm giving the name as mat. Mat is equal to directly I'm using this thing, curly bracket 1 comma 2 comma 3, first row, comma, next braces 4 comma 5 comma 6, comma, next brace, next brace means third line, so 7 comma 8 comma 9. So if I write this thing, I don't get anything now. Same thing if I run this thing, if I evaluate this thing, same thing I will get. I don't get any matrix form. So to get matrix form, what I need to write? Okay, mat backslash 2 times matrix form. Matrix form. Then shift enter. Then 1 2 3 4 5 6 7 8 9. This is a matrix form of that. Now here anything we can find after writing matrix. We find the inverse of the matrix, eigenvalues of the matrix, eigenvectors of the matrix, and multiplication, addition, anything we want we can do here. Trace, diagonal, what is the diagonal matrix, what are the elements here, what is the transpose, everything we can do within a single line. Suppose I need to form a diagonal matrix. Simply what you need to write? Diagonal matrix of the diagonal elements we need to write here. Which diagonal elements you need? So I need 3 4 5 6. These are the diagonal elements. If I run this, I don't get any matrix form. Let us check here. This is only I get, but I need this in terms of matrix form. If I need the matrix form this, then what I need to do? 2 times backslash, then matrix form, then run, then this is a matrix, diagonal matrix. Similarly, you see constant array. Let us check here what it is. Constant array. Constant array of, I'm writing 3 here, 3 comma 2 comma 4, 2 comma 4. Now run. Okay, all threes, and suppose if I want to write in terms of matrix form, that will be very easy to evaluate, easy to look into that. Matrix form of this, you see 2 rows 4 columns, all threes. 2 rows 4 columns, all threes. Suppose if I write 4 or something else, 10, 7, then like that. Suppose here if I write 20, if I write 20 rows, 4 columns like that. Suppose if you want to find eigenvalues of some matrix, so simply generally there will be some characteristic equation, then solving that we will get some cubic fourth root fourth degree polynomial, then we have to solve. There is a lengthy process, but here simply in one line, eigenvalues of the matrix we need to define. The matrix is first line is 1 comma 2. First line is 1. 3 comma 4, let us take 3 comma 4. This is 2 by 2 matrix. First line is means first row elements are 1 comma 2, second row elements are 3 comma 4. Then enter. You see the eigenvalues of that matrix are half 5 plus root 33 and half 5 minus root 33 directly. Two eigenvalues are there for 2 by 2 matrix. Then those are the eigenvalues. Similarly, if we want to find the eigenvectors, same eigenvectors a single line will get the eigenvectors. Then same matrix I am copying here, copy, then here paste, then evaluating the cell, then these are the value corresponding eigenvectors. Hello. Hello. Hello, any doubt? Okay. Okay, these are the eigenvectors corresponding to those eigenvalues here. For this eigenvalue, this is the corresponding eigenvector, and for this eigenvalue, this is the corresponding eigenvector. Okay, now if I want to find the determinant of the matrix, simply what we need to do, date of that same matrix I am copying here. So shift enter, the determinant is -2. Suppose if I want to find the rank of the matrix, simply what we need to write, matrix rank.
Sir, can you explain me the eigenvector, sir?
Hello.
Sir?
Haji.
Hello?
Haji,
eigenvectors. I am not getting eigenvectors.
You see, this is eigenvalue. Hello.
Yes, sir.
Then this is eigenvector for that. Not getting?
Okay, okay. So this comma 1 means it is an eigenvector for the first value?
Yeah.
Okay.
There are two eigenvectors generally. For there are two eigenvalues means there should be two eigenvectors.
Yes, sir.
Yeah. First one is first eigenvector. Second one is this one. For this is first eigenvector. For this one is the second eigenvector.
But so what about the one?
What about the ones?
XY, you see, XY eigenvector means the solution. XY. Non-zero
No, sir,
vector.
that one means
Okay.
what?
Okay, sir. Got it. So this is my x1.
Yeah, x1, x2 we find x1 and x2 values. This is x1, this is x2.
Right. And in x1 I have y coordinate as 1. Right.
1, yes.
Yes, sir. Yes. Thank you.
Clear?
Yes, sir.
Yeah. Now coming to matrix form. Oh, sorry, matrix rank, not form. Matrix rank of the matrix. Rank of the matrix is same matrix I am taking. 1, 2, 3, 4 only I'm taking. Then shift enter. The rank of the matrix is 2. Okay, means like this we can find eigenvalues, eigenvectors, determinant, rank, and inverse also we can find. Inverse of same matrix I'm using. If you want, you can use any matrix, that is your wish. So inverse of the matrix is this thing. So if I want to write in terms of matrix form of this inverse, so backslash matrix form, then this is the inverse of that matrix. Now suppose if you want to find the transpose of the matrix, same matrix, transpose of the matrix, same matrix I'm using. So transpose is this thing. Suppose if you want matrix form, backslash matrix form, then shift enter. Then trace. If you want, you can find trace of the same matrix I'm taking. Trace of that matrix. Sorry. 1, 2, 3. Is it right spelling trace? TRACE?
Yes, sir.
The matrix form we have to write or what?
No, trace means I think we will get only that value number will get. Okay, trace is not working. Let's check. Okay. Could please check in the Google how it is not working. Actually, it should work. Okay, there's some error. There is some error. Trace. Let's check later. Okay, now similarly, we find all these values, and suppose if we want to add, subtract, do multiplication, and eigenvalues of some combination of matrices, we can do easily with the help of matrices. You see, generally already mat matrix we are having now present. Mat means I am using this thing. The matrix is this thing. Then one more matrix I am defining. MATT is equal to some other matrix 1 comma sorry comma next means first row belongs to first bracket belongs to first row, second bracket belongs to second row, 6, second row is 1, 7, 9, and 2, 5, 7. Now this is my matrix, second matrix. Now I need to find a matrix mat plus mat. Check. Is it right? Yes, 1, 2, 3 there. 1 plus 4, 5. So if you want to write matrix form, you write. Let us check here why it works or not. Matrix form. Matrix form. So this is the matrix. So 5, 7, 9, 5, 12, 15, 9, 2, so on. Suppose here if you want to add 10, 10 into second matrix. So if I run this thing, suppose if I want to find a matrix or what is that? Eigenvalues of this mat plus 10 mat. Simply eigenvalues of this thing. Directly you will get eigenvalues. Similarly eigenvectors and so on. Each and everything you will get. Okay, any doubt in the matrices, how to represent the matrices and so on? Anybody?
Hello, sir.
Yeah, Ji, please.
I think for trace, we have to consider only TR, then it is working.
Okay, TR. Thank you. TR of this. Yeah. No, it is TR. Okay, this is it has taken, I think so. 70, 70, 140, 180, 195. Yeah, it is working. Sorry, that is not trace, TR. Yeah, thank you. Getting this matrix, it is calculated because here our previous answer is this thing. Clear? This is 36. You see, this is outline output of 136. This is output of 137. That's why this percentage means this has taken. Clear? Yeah. Thank you. Now, next we go for any doubt?
Sir, here element-wise multiplication not performed.
Element wise. Okay, good. For element wise matrix multiplication, I will check here.
Hello.
हाँ जी बोलिए.
Sir, what is exactly the role of percent? I mean, I didn't get why it has taken the letter matrix.
Percentage means the last outcome.
Okay.
Okay, last outcome was this matrix.
Okay.
For this, the trace is 195 like that. Okay.
Okay, sir. Yes.
Yeah. So there is an option element to element multiplication, but 4 into 1, 4. Please search on Google. Actually, I don't have an idea because we have not used that thing at present. Element wise multiplication is there. I know that, but how to use that we have to think about. This is your matrix multiplication.
Can we put dot star?
Yeah. If I put a star, I'm getting element wise multiplication. Dot means matrix multiplication. Star means element wise multiplication. Clear? Yeah.
Yes.
Yeah. Now very important topic is now plotting now. So two main important topics now, plotting and differential equation. How to solve differential equation and how to plot. Okay, there are various types of plots are there in your research area. Whatever your research area is there. Okay, the graph should be clear and that should be beautiful. Okay, then only the journals will publish in a good quality publish. Okay, that means the article should be published in a good quality journals. Okay, mostly generally nowadays the reviewers are not seeing your work, how you have presented that work. in terms of results and discussion and graphical graphs. Okay, those are main important nowadays. So now we are discussing plotting. So there are many types of plots are there. General simple plots are there, list plots are there, 3D plots are there, contour plots are there. Many plots are there. Now we are going to discuss a few of them. Now, first one is I'm plotting one function. My function is x square upon x square upon 4 minus x square 4 minus x square 4 minus x square. This is my function. I am plotting this. This is my function. I am plotting this in the range. In the range x from minus 5 to 5. Minus 5 to 5. Okay, in the range minus 5 to 5, I am plotting the function x square upon 4 minus x square. So shift enter. This is my result for that. Okay, you see, suppose this is we got the plot. Okay, if you want to increase or decrease the font size or this thickness, we can use any we can use these things. Then change the background thickness and change the color. Everything we do using these things. Okay, background or thickness of this graphs or moderate. Suppose if we want to modify these graphs, actually don't modify this graph. Okay, if you want, we can modify according to our choice. Suppose if I want to increase the thickness or something, we can go to drawing tools. Then there are many options will be there to change the color, font size, so on. We can change those things. Okay, now according to our choice, we can change those things. Now suppose if I want to find the trigonometric functions are there, I need to plot those things. Plot of sine of x. Two functions are there. Suppose I am having two functions now. Two different functions. Sine of x, comma cos of x, these are my functions. Now I need to define the x range. X range is x comma 0 comma 2 pi. This is my range for x. Then if I need to evaluate this thing, then this is your plot. But I don't know which one is belongs to cos sin x and which one is belongs to cos x. But colors are different. But I don't know which one is belongs to which one. Okay, for that we need to give the legend commands. We need to give the legend commands. Okay, but moreover, we don't know which is x-axis and which is y-axis. We don't know. Okay, now for that we have different things are there. Those are, you see, for defining which color is belongs to which function. For that we need to use legends. That is those are called plot legends. Plot legends. Plot legends. Simply we need to define expressions like simply expressions. Or if you want, you can write anything. Expressions. If you write expressions, simply directly automatically it will takes the result. You see, blue line represents sin x and orange line represents cos x. In place of this, you can write any of your x is equal to this thing and y is equal to this thing. You can write anything. Now, if I want to write labels also, x labels and x label and y label, means x which is x axis and which is y axis. It means x axis में क्या होना चाहिए, y axis में क्या होना चाहिए. So for that axis labels we need to add axis labels. Axis label implies, so I need in place of x-axis represents, suppose I'm writing Ramesh, okay, then comma, and y-axis represents SIT, then let us, sorry, this should be in braces, in this quotes. Okay, now on this thing you see x-axis is Ramesh and y-axis SIT. Then suppose if you want to fill, suppose otherwise okay, we want to fill some gaps. You see here, if we want to fill some gaps, so what we need to do, gaps means if we want to what is it, filling some color with some in between that curves. So for that we use filling sorry filling implies I'm using here 1 to 2, first curve to second curve, first curve to second curve. Let us check what will happens. Filling 1 to 2, sorry, this is implies, that is not minus, it implies, check, yeah, see, fill up was there from first curve to second curve. Okay, filling has done. Okay, now suppose if you want to use different colors, if you want to can use different colors, then you can use the colors also. You see there is a one more color function option is there, comma, color function. I'm using some rainbow. Let's see what happens. Rainbow. Otherwise also we have different things are there. Okay, I'm using rainbow color function for that thing. I got this kind of thing. And for different suppose here inbuilt colors are there for first curve and second curve. First curve is blue and second curve was orange. So to change the colors we have different option is there. Suppose मुझे blue अच्छा नहीं लगता है, I don't like blue, I need red in place of blue, then you can use plot style. Okay, plot style you can use. Plot style implies, okay, there are two lines are there, one is for sin x and other one is for cos x. So curly bracket, first one I need a green, so green, and second one I need yellow or something else, or red. Okay, if I run, अभी ऐसा नहीं दिख रहा है, but these colors have changed. You see, let us check here. If I remove this thing, if I remove this thing, क्या change होगा या क्या नहीं? Yeah, you see, it is green and it is red. Okay, like this we can use the plot style colors also. And suppose I don't want this like a thick line. I need some dots. Okay, you can use those also. You can use those also with the help of a dashed line for green and thick line for yellow and so on. Like that, you will get the things.
Sir,
Hello.
sir,
हाँ जी बोलिए.
green color for we have not given any such command. Na?
Hello.
Hello.
Aparna, please. You are not audible, please.
Okay. Hello. Am I
हाँ जी.
audible, sir?
Yeah, now it is
Sir,
fine.
yeah. You removed the rainbow command and now it is showing filling area with green color. So how it
Yeah.
happened?
No, I have not. You see here in rainbow color, there that is a mixed colors of WebGR. Okay, that's why it was not showing clearly.
Okay.
That's why I have removed that WebGR means rainbow color. That's why it is it is visible. That was there also, that was there, but that is not visible clearly because of multiple
So,
colors.
sir, I am asking the filling area has been filled with the light green color.
Yeah.
So how that has happened? We have not given now any command for color.
Yeah, this is
to fill
automatical.
the-
This is automatical. This you want to change, you can change. This is automatical.
Okay.
Yeah, if you want, you can change. Give the filling color also. Okay. Yeah. Now this is about uh, simple plots. Now we are going for list plots. Okay. Now you see here, I'm giving some data. I'm giving some data. Data is equal to like table of sine of x square plus y square, sine of x square plus y square, x square plus y square, x is range is x range x range is 0 to pi, 0 comma pi, 0 comma pi. Okay, in the gap, in the step size, pi by 30, pi by 30. Similarly, y, same thing I'm taking. Okay, from this line we get some data points y. Okay, now this is my data. This is my data. I need to find 3D plot, because here there are two variables. I have not discussed about one variable, because okay, I will discuss that also. No problem. I'm giving some one more data. Data 1 is equal to I'm writing one more function, one more table. Copy, paste. Here I'm taking only x square. Simple for simple curves. Simple data points. Yeah. Now data 1 is there. Data is there. First of all, I'm plotting the data 1. So that is list plot I'm using. List plot list plot of data 1. You see what happens. I will data 1 list data 1, not a list number of pairs of numbers. Okay, when we are having suppose we need to write it instead of this one. If we write that thing, we will get. Okay, we'll look into other thing. List to point plot of 3D data I'm using. Suppose it works out not. Okay. Okay, it is not functioning. It is not taking table. We need to write some data points accordingly. Accordingly, we get the plots for this. Okay, I have given the function and I have given the range. Okay, it is not taking like this. So table is not working. Instead of table, we need to use some other thing here. Then that will works.
It is working, sir.
Working?
Yes, sir. I have written list plot data 1 and graph is showing.
But it is not working here. I don't know. Otherwise also, if it is not working, it should work actually, because earlier it was working. Okay, if it is not working also, suppose we are having some data points. With the data points, we need to write all the data points in the braces. Then we need to plot that. Okay, for that we need to use list plot. What about it? Is it working, this list point plot 3D? Yeah, now it is working. Yeah, it is working now. I don't know. Okay, it is working. If it is not working also, use that data points, then write those data points, then plot these things. Okay, this is your normal plot, list plot, and this is a list point plot 3D. Similarly, list plot 3D for the remaining many things are there. Okay, for all the things, these are common. If you want, you can give legends, access labels, filling, plot style, color style, everything you can include after plotting. Those are common for all graphs. Those are common for all the graphs. Now this is your list point. Point means all the points are there. Suppose in place of list plot, list point plot, I'm using different thing. List plot 3D. List plot 3D. List plot 3D. List plot 3D of data. List plot 3D data. Okay, this is your list plot 3D of the given data. The data was sine of x square plus y square in the range 0 to x range is 0 to pi, and y is range is 0 to pi. Suppose same list plot, but I'm using contour plots. List contour plot. List contour plot. List contour plot of data, whatever the data was there, data. So shift enter. This is your contour plot for that. Now suppose if I write 3D, what happens? Let's see. It is 3D. Oh, some error came. Okay, it is not working 3D. So yeah, this is list plot, list contour plot. Now this is about the plot list plots. Now we are going for 3D plots, region plots, and we go for different kinds of plots. Okay. Now suppose I'm taking same function x square plus y square. The range is different. Let's see what happens. Sine of x square plus y square. Copy. Plot 3D. Plot 3D. X range is same thing in terms of different limits. -3, 3. In y range is -2, 2 I'm taking. Y comma -2, 2. Okay, suppose if I want to evaluate this thing, this is a plot 3D. And suppose a region plot is there. Let us check region plot works or not. Suppose a region plot I am taking. Region means some less than 2 I am taking. Suppose I am writing here region plot. Region plot. Region plot for this. Let's check. Implicit Boolean combination equations. Sorry. Now this is your region plot. X square plus y square less than 2. So this is your region plot within the range -2, 3 to 3, and y range is -2 to 2. And similarly, suppose there are two functions. There are two functions for region plot. We need to find. Those functions are x square less than y square plus 1. Suppose plus 1 or plus 2. Then y square comma y square less than x square plus 1. X square plus 1. Okay, there are two equations are there. That's why we need to write those in one square curly braces. Now let us check how it works. Region plot. This is a region plot for that. Okay, like this we can find the plot 3D on the region plots of a single equation and multiple equations. And contour plot. For contour plot, already we have seen contour plot for in the list. Now generally suppose two functions are there. We need to define if we are in x limits and y limits, then how to find the contour plot. We are saying now contour plot. Contour plot. Contour plot of cos x cos y. cos x plus cos y, cos of x plus cos of y, cos of y, comma, I need to define x range and y range. I need to define x range and y range. Then my x range is x comma, I'm defining x range 0 to pi, 0 comma pi, and y range is also I'm taking same. Y range is I'm taking same. Now let us check. This is a contour plot. Now suppose contour 3D plot we want to find. 3D, contour 3D. Okay, for 3D we need to have one more expression. Let us take Z. Let us take Z limits are from 0 to pi. Z range is 0 to pi. Okay, this is a plot for cos x plus cos y plus z in contour 3D plot. Okay, like this we can find different types of plots: 1D, 2D, 3D plots, contour plots, list plots, anything. Okay, these concepts are same for all the graphs. Wherever you want, we can use, and we can manipulate these plots according to our choice by using with the help of this नीचे कुछ रहता है axis से, or then if you want to click on the like graph, then if you write a
Sir, please show the last graph contour Z by adding Z.
you're not getting?
No, I'm not getting. Just
Yeah, contour plot 3D I have written. There should be 3D.
okay.
Yeah. Okay, like this we can use the plottings. Now we are going for differential equations. There are two kinds of differential equations are there to solve. There are, sorry. Yeah, there are two kinds of differential equations. There are ordinary and partial. Okay, those also we can solve using this Mathematica. accordingly, accordingly, we can find the behavior of the solution with the graphs. With the graphs. Okay, now first of all, we start with ordinary differential equation. Okay, then we need to find the solution of that with the conditions and without the conditions. Means initial or boundary conditions. Okay, now suppose there is an equation here. We need to use D solve for differential equation. Differential solver. Okay, D solve for solving differential equations. Okay, D solve of my differential equation is dy by dx. My differential equation is, you see, dy by dx. First differential equation I'm taking as dy by dx plus y is equal to 1. I am solving this equation. Dy by dx plus y is equal to 1. I am not using any conditions to solve this equation. For that, what I am doing, D solve y prime of x. Dy by dx means y prime of x. Y prime of x. Y prime of x plus what is the next term? Y. So y is a function of x. That's why y of x is equal to, here we are solving, so we need to use 2 times equal, then 1, then 1. This is my equation. We have to solve y, so y is a function of x. Always we need to write this y of x and so on. Y of x, then what is my independent variable? My independent variable is x. This is my simply in one line I have given the differential equation. Y prime x plus yx, sorry, there it was missed. Y of x, okay, sorry, yeah. Now this is a differential equation, and we need to solve for y, and the independent variable is x. Simply shift enter. Your result is, you see, y solution is 1 plus e power minus x c1 of x. Whenever we are finding the solution of differential equation, there will be some arbitrary constants. Here where c of 1 gives us arbitrary constants. Okay, if I give some condition, then that will be evaluated. Okay, but how we need to give the condition? That is the point. Okay. Now okay, my condition is, suppose I am writing one condition. Suppose I am giving condition I need to mention here. This is my equation, I got the result. Okay, same thing I am copying for avoiding confusion. Copy this one. I'm using condition. Okay, the equation as well as condition we write in a bracket first. So that is my first equation. Then I'm using some condition. Suppose my y of 0 set 0 is x is equal to 0, my y value is 1. Suppose this is my condition. Okay, whenever I am using the condition, then there will be no c1, means arbitrary constant, that will be evaluated. Okay, sorry, here I have not used 2 times equal, that's why it is coming out like this. So 2 times equal. Now evaluate. What is this? Equation list, equation expected instead true, first argument. Okay, it is coming out. I don't know, that is not working. It is x is equal to 0 means that maybe gives us some infinity thing kind of things, I think so. So like this we can give the conditions, and suppose this is a first order differential equation. Suppose if you want to find the second order differential equation or third, fourth order differential equation, you see same d solve of my differential equation is fourth derivative of y, 1 2 3 4, fourth derivative of x is equal to y of x, y of x, y of x, comma, I need to find y of x and independent variable is x. So this is your solution without using conditions. If you want, you can use 4 conditions. We need to use 4 conditions to evaluate that C1, C2, C3, C4 values. Here we have given one condition. That's why C1 is evaluated. Here we need to have four constants are there. We need to have 4 conditions. Those conditions we can give here. We need to give there. Okay, whenever we give there, then the 4 constants should be evaluated. Okay, now any kind of differential equation we can solve like this. Now suppose you are having some numerical solution. Okay, numerical differential equation is there. We are talking about only ordinary. That's why first of all I need to finish the ordinary differential equation. Then I go for partial differential equation. You see any differential equation you give like this, then in curly bracket, suppose conditions are there in curly bracket, entire things means equation as well as conditions. Then comma, which one you are evaluating, that thing. Then what is the independent variable, that thing. Those things you need to mention. Okay, suppose here itself, first of all, here itself before going to numerical differential equation. Now suppose simultaneous differential equations are there. Simultaneous differential equations, the equations are there. Then how to find the solution of that? So I am giving some name for differential equation or with the conditions. Otherwise it will be very complexity we will get here. You see here there are some complex terms will be there inside. First of all, I am defining this thing with some variable. Suppose ds, I am defining ds is equal to there is a lengthy expression, that's why I'm defining this. Otherwise also no problem, that is your wish. X double prime of t, my independent variable is t here, is equal to 2 times is equal to y of t comma x of t plus y of t is equal to 0. These are my simultaneous differential equations. Okay, I am defining the conditions also. My conditions are x of pi is equal to 1, x of pi is equal to 1, comma x prime of pi is equal to 0. So this is my equation accordingly conditions. I need to solve this equation. Two simultaneous equations these are. So d solve of, okay, my equation with conditions is given by ds now. I don't write here now entire thing. So suppose if you are not mentioning ds, then you need to write entire thing here. Comma, we are evaluating two things here. One is x and other one is y. So x is a function of t and y is a function of t. Y is a function of t. Now your independent variable is t. Now your independent variable is t. Now we are solving this. Let us check. Yeah. You see, x is equal to minus cos t, y is equal to cos t. Okay, suppose if I remove that conditions, if I remove that conditions here, you see I am removing these conditions, then what happens we'll see. So there should be C1 C2 100% होना चाहिए. You see those are with arbitrary constants C1 C2 C1 C2 x and y. Okay, why it is repeated here? Same equation, because we have not I think we have not mentioned here semicolon, that's why that is repeating. Let us check. Yeah, you see, if we are mentioning semicolon, that is not reflecting that thing, otherwise that is reflecting. So I have not used any conditions here, therefore I am getting in terms of C1 C2 are arbitrary constants. If I am using conditions, that is evaluating C1 C2 also. Okay, like this we can use Mathematica to find the simultaneous differential equations as well. Now coming to numerical differential equations. Numerical methods means there are many methods are there, like Euler's method, modified also Euler's method, Rangi-Kutta method, and the Boole's method, so on. Sorry, Boole's is not comes under here. Okay, there are many methods are there. Now based on that we can find the solution here. Now generally we do, suppose we are not giving the method name, we are not giving the method name, automatically it will take this any method. If you are mentioning the method name, but it will calculate as per our method, as per our method. Same, only in place of dsolve there should be ndsolve. N stands for numerical. Ndsolve. First time we discussed dsolve, there ndsolve. Okay, in our paper we used ndsolve because here that was complex problem. Okay, ndsolve. Okay, here also same set of equations along with the conditions and variables which we are finding, then which is your dependent variable, independent variable, those things are there. Okay, now here first of all set of equations we need to write, then dependent variables we need to write, then we need to define what is the independent variable range of independent variable, that we need to mention.
Sir.
Hello.
Hello.
हाँ जी बोलिए.
Sir, in line number 79, x double dash of t, what is that, equal to, or I'm not getting.
No. You see here, this line I have written. I think it is visible. I have in blue shaded region. Is it visible?
Yes, sir.
You see here, there is no semicolon. There is no semicolon for this line. That's why that is same as it is given there.
Okay.
Okay, if I mention here semicolon, it will not come.
Okay.
Okay, like that. Now here coming to numerical, and any doubt?
Which we are not getting, that's why. The output is not getting, that's why.
Output, okay. I think you missed your two equal signs. I think so.
No, I have already. Okay.
I think you missed this x of t, y of t.
Okay.
Okay.
I have written, sir, everything. Yes,
okay.
sir, that is missing.
Missing,
Yes.
Yeah.
Okay.
Okay, fine. Okay, thank you. Next, ND solve. Okay, I'm giving one equation, that is d square x by dt square is equal to d square x by dt square. Sorry, dx by dt whole square. Okay, now my equation is d square x by dt square means x double prime x double prime of t, d square x by dt square is equal to dx by dt whole square means x of t whole square, x of, sorry, on dx x of t whole square, that's x square simply, there is no derivative, x of t whole square x of t square, x of t square. Now my conditions I am defining, conditions are, boundary conditions are, or initial conditions, x of 0 is equal to 1, x of 0 is equal to 1, comma x prime of 0 is equal to 1, x prime of 0 is equal to 1, here 1 is equal to missed, then this is my equation, and along with the boundary condition, along the initial conditions, then my variable, dependent variable is x, so x of t x of t, then I need to define the t range. T range, why we are defining the t range? Earlier we have not defined the t range, because here in the numerical solver we don't get any solution, but we get the behavior of the solution in terms of graphical representation. So here we have to give the equation and give the conditions as well as the range of independent variable. Means your plotting should be from which range to which range. That we need to mention because earlier here that was a direct method, so that's why we are getting the solution. But in ND solve we don't get the solution, but we get the behavior of the solution using the plots. So here for that reason what we are doing here is directly we are using plot command. Plot, okay, plot, okay, plot, here plot, here we are evaluating x of t, because here we are finding x of t, dependent variable is x or x, so we write evaluate x of t, x of t, x of t. Now careful about it, backslash and dot, backslash and dot. Yeah, let us take here. Let us define, this is my function q. Let us check here it will work or not. Q comma t comma 0 comma 2, t comma 0 comma 2. Yeah, there was a comma missed, that's why the error was getting. Okay,
You see here like this, directly the behavior of the plot we get directly. Now only as I said earlier, okay, with the help of Mathematica, we got the solution. We don't give anything directly. We give the plotting of this in the paper. Okay, like this we can find the numerical solutions. Now please evaluate. Understood means what you need to write. ND solve the first equation along with the conditions, dependent variable, then T range. Then in the plotting, plot evaluate of that dependent variable backslash dot that function whatever we have defined earlier for the differential equation. Then T range. So you see why it is 0 to 2. See T range is 0 to 2. 0 started here 2. Suppose here you are mentioning 5. Here 5 that comes up to 5. There is a difference. That's it. This comes up to 5. Okay, like this we can get. Okay, if it is 1, then we get up to 1. Okay, like this we get. Okay, similarly we can evaluate the simultaneous differential equation also in numerical differential equations. Okay, if you want you can specify the method also. Method same whatever earlier decided method implies shooting method, Rangikuta method, anything. That method you need to define. The method implies in quoted lines shooting method. Okay, like that we need to mention if you want. Okay, now I'm going for simultaneous differential equations. I'm going for simultaneous differential equations. So for simplicity, I am copying this as it is. Copy. Okay, ND solve. My first function is, first differential equation is x double prime of t y of t means d square y by d square x by d t square plus is equal to y. This is my first equation. Sorry, plus y is equal to x. No problem. If you want, you can use that also. No problem. X of t. Then my second equation is x of t square plus y of t square is equal to 1. Means x square plus y square is equal to 1. If you want, you can use the differential equation as well here. X of t square plus y of t square is equal to 1. Then here I need to mention x limits as well as y limits. Let us check. Okay, I'll keep as it is, this one. Let us check how it works. X of t, y of t, because those are my dependent variables, those I need to solve. Then here here my dependent variables are 2. Here my dependent variables are 2. So here I need to write in braces comma y of t, then my t range should be 0 to 1 or 0 to 2? Okay, let's check. There was one more equal sign is missed. And are you getting anybody? X double prime of t plus y of t is equal to x of t x square plus y square is equal to 1 comma x of 0 is equal to 1 x prime of 0 is equal to 1. I think is it if it is 0 then it is
Sir, after Q1, we have to put semicolon or it is not necessary?
no comma only, that is.
No, this Q1 line, this...
Yeah, that is not necessary. That is not necessary. Okay, if we put semicolon, this will not come. That's it.
Okay.
Yeah.
It is showing some error, sir.
Yeah, it is showing some error. Somewhere it is went wrong. There are fewer dependent variables than equations.
Sir, is there
Okay,
any conditions for y?
yeah, there should be. Okay, we'll try to search one differential equation, then we type that thing. Yeah, we tried this thing with the conditions we need. Yeah, we choose this thing dy by dt. dy by dt is equal to minus y 3 plus x. So y prime of t, y prime of t is equal to y prime of t is equal to minus y. There may be error in the equation, that's why that is getting error. Minus y minus y minus y plus 3x minus y plus 3x 3 into 3 into x of t. Then next equation is dx by dt 4x minus 2y 4x minus ty 2y 4x minus 2y 4x 4x minus 2y. So this is x of t, this is y of t. There should be two equal signs, minus y plus 3x. Okay, y of 0 is equal to x of 0 is equal to 1, y of 0 is equal to 2, y of 0 is equal to 2, x of 0 is equal to 1. X of 0 is equal to 1. Okay. Then let us check. Equation list, equation expected instead of false. This should come because here earlier yesterday it was working. I don't know why it is not working now. Anybody got the result?
Same result like you, sir.
Okay. Something is missed. Otherwise, it will work. Okay. Let's check later. Okay, please check this later how it works. Once try on Google, definitely you will get. Let us try other last one. ND solve. ND solve. Only one equation I'm giving now. Presently, I will check it works or not. Y double prime. Y double prime of t plus y of t y of t upon 4 upon 4 is equal to 8. 8 conditions are y of 0 is equal to 0 and y of 10 is equal to 0. Then your dependent variable is y of t, and range is t comma 0 comma 10 0 comma 10 Then same evaluate. So for this I am giving some name, WE. So now evaluate, plot evaluate, this thing I'm using, plot evaluate y of t and WE, then t is equal to 10. Yeah. Okay, this was working. Okay, first plot is working. The same line, in the same line we are doing the remaining things also. Where we missed? It will work or not? No, it is shift enter. Okay. Okay, I will check. I will check. I will check and let you know why it is not getting, and I will send the codes as well. I don't know, some error was there in the Mathematica. That's why it is not running. So anybody is getting any answer of this? Actually, it is case sensitive. Somewhere, if it is missed something, then it will not works. Evaluate y of t backslash dot. Okay, no problem. I will send the details of this, why it is working and why it is not working with the reasons. Okay, thank you, and ask me if you have any doubts. Any doubts are there? Okay, I will send the programs as well of differential equations, and I will give the reason where it is not working. It should work because it is working, because those should also be work and dissolve. Yes. Okay, in the software there might be an error. I will tell you later. Okay, I will give you the sheets also. I will prepare the sheets and then send you. I will send you. Then ask me if you have any doubt. And moreover, this is your Mathematica, and we have finished. I will send you the programs soon by today or tomorrow. And one assignment I am going to give based on Mathematica, and the marks for that, the total marks for that are 5. You use a trial version or online solvers, that is your wish. And for linear algebra, I'm going to give 10 or 15 questions. That is a quiz. Okay, most probably that will be in the next week. Okay, for the linear algebra, there will be 20 marks. There will be 20 marks for linear algebra and 5 marks for this Mathematica. Simply this is assignment. Either you can use a trial version or online solvers. Okay, the linear algebra should be quiz, like multi MCQ question paper. The particular time will be there. Accordingly, please prepare